This is the question asked in today's skillrack daily challenge. In the first line of our input, we are given the value of integer n. So here n is equal to 20. So the range is 1 to 20. So we have to check whether we can print the integers in the range 1 to 20. But the smallest prime number is the integer 2. But 2 is an even number. So the smallest odd prime number is the integer 3. So instead of checking in the range 1 to 20, we will be checking from the range 3 to 20. So we will be checking for all the integers in the range 3 to 20 whether it is possible to print that integer or not. So the condition to print that integer is the previous integer and the next integer must be odd and it must be prime numbers. And there will always be only one integer present between two consecutive odd prime numbers. So for the integers in the range 3 to 20, let us start checking whether we are able to print that integer or not. So for the first integer 3, the previous integer is 2 and the next integer is 4. So 2 and 4. So 2 is a prime but it is an even number and 4 is also even. So we cannot print this integer 3. So the next integer in this range is 4. So the previous integer for 4 is 3 and the next integer is 5. So 3 and 5 both are consecutive odd numbers and both the integers 3 and 5 are odd. So we can print this integer 4. So in our output also we are printing the integer 4. And the next integer in the range is 5. So the previous integer for 5 is 4 and the next integer is 6. So both are even numbers. So we cannot print this integer 5 in our output. So we move to the next integer in this series. So the next integer is 6. So the previous integer for 6 is 5 and the next integer is 7. So the integer 5 and 7 are consecutive odd integers and they are also prime numbers. So both the integers 5 and 7 are odd. So we can print this integer 6 in our output. So in our output also we are printing this integer 6. So like this we should check for all the integers in the range 3 to 20 and whenever the conditions are satisfied we should print those integers in our output. Now let us see how to write a C program for this. So first I am creating a new integer n and in the next line I am accepting the value of the integer n using the scanf statement and then I am creating a loop that iterates from 3 till n. So the loop starts from 3 and iterates till I less than or equal to n. So in every iteration we will be checking whether we can print the current integer or not. So if we need to print the current integer, then the previous integer and the next integer must be prime. So using a if condition, I am checking whether the integer I minus 1 and I plus 1. So I minus 1 is the previous integer and I plus 1 is the next integer. So I am checking whether both of the integers are prime or not. Here we don't check whether both the integers are odd because all the prime integers except 2 will be a odd number. So if both the conditions are satisfied, then we print the integer I. And to check whether the integer is prime or not, we make use of this function isPrime. So this is a user defined function. So now let us see how this function isPrime works. So this function isPrime accepts the integer n in its arguments and returns 0 if the integer is not a prime. And if the integer is a prime, then it returns 1. So to check whether the integer is a prime, we will be iterating from 2 till the square root of n. And in this range, if the integer n has a factor, then it is not a prime, else it is a prime. So within this loop, I am checking whether n mod I is equal to 0 or not. And if it is true for any value of I in the range 2 to square root of n, then this function returns 0. Else finally after the execution of this loop, this function returns 1. So this is how this function isPrime works. So now let us check our program with the sample test cases. So now I have given the sample input 1 and for sample input 1 our expected output is here 4, 6, 12, 18. So we also print the same integers. And now for sample input 2 our expected output is 4, 6, 12, 18, 30, 42. So we also print all these integers. So this is the logic behind today's daily challenge. Thank you for watching.